Perfect. So I guess, sorry guys for that mishap. Some of these technologies, we get used to them as we move forward. Zoom, Google Words. So forgive me for that. Next time we'll spend a shorter time. Welcome guys. Today the session is going to be run by Eunice. She had communicated in the group. It's a good turnout and it's some interesting stuff. I was just skimming through the notebook. Very, very interesting. We might not cover all of it, but today's session is to trigger your interest in a library called spaCy. I suspect most of you guys have come across it. And in particular, today's session will be something called NER, Named Entity Recognition. So over to you, Eunice.
All right, thank you, Ayub, for that introduction. So if this is your first time, maybe you were not in the group the other time, then I sent the YouTube link. So hopefully you watched it. If you didn't, I think you'll still have to watch it because you might miss a lot, because this is a new notebook. It's not a continuation of, it's a continuation of what we had, but it's a different notebook. You won't see what we did last time. So last time what we did, okay, our major goal here is we have 3 data sets. One data set that is the trained data that contains the text ID, the selected text, the text, and the sentiment. And then we have the test data that contains the text ID, the text ID, text, and the sentiment. It does not have the selected text. And then we have another data set called submission data set that only has the text ID. So what was required from this, it was, what is it called? A competition. What was required from this competition is to be able to predict the selected text that was used to get the sentiment in the test data, and then use it in the submission data, because it only has the text ID. So what we did last time is we visualized the trained data. We imported it and then visualized. We looked at the Jaccard score. We looked at what else? We looked at all the visualizations of the wordings. We looked at word clouds. We removed the stop words. So we did a lot of stuff. So if you are not in the session, then I would kindly request you to please check the link and check it out, because we will not do the same here today. So what we're going to do today is continuation with the modeling. So first of all, we import the necessary libraries that we will require in this notebook. So you can see we have regex, NumPy, Matplotlib, TQDM, just to mention a few. So down here is where we are mounting the drive and loading the data. So since I was using Colab, you have to load your data set in your Google Drive. So this is how you mount it. And then this is where I call in my data. I have DF train, as I explained, I have DF test, and then I have DF submission. So after that, I want us to look at the train data. We looked at it the other time. So, but now I just want us to have a gist of how it looks. So it has text ID, it has the text, it has the selected text, and it has the sentiment. So this number of word text is something that I created just down the notebook. You'll see it. So which contains the number of words in the text. Okay, so we go down and we scroll down kidogo.
Yeah.
So yeah, there. So let's talk about the modeling that we approached in this specific task. After going through some discussion forums and looking into what other people have done and borrowing some from what others have. You see, there are methods of learning. You can learn something from scratch, and which you will take a longer time, and you can learn something from somebody else and maybe take a different approach, which you will take lesser time. So it's you to choose how do you want to do your task. Yeah. So after doing some research, we discovered that we can model our problem into these two models. We can use a named entity recognition, which is NER, or we can approach this problem as a Q&A problem and then model it. So first, now we're going to just look at the NER because we found out that the Q&A problem won't really help in this case. So modeling through the problem through as an named entity recognition, which is a standard NLP problem that involves spotting named entities like people, places, organizations, and etc. So from a chunk of text that is given, this NER classifies them into predefined set of categories. It already has those categories, the people, places, organizations, and stuff. So, and locations and such. So for understanding, we have put links in our notebook just in case you go through it and maybe you want more information about it. And also, as I shared the prerequisites of this class, we shared a link to spaCy, which of course would help you to understand NER. So hopefully everybody went through the link. Otherwise, if you didn't, okay, utafloat kidogo, but I propose that you just go through the notebook because it has the link, because it has a lot of stuff that we cannot be able to explain in this session. So we decided to use spaCy for creating our own customized NER model or models. Last time, okay, I'll be referring to very many instances that we have done. So last time when Ayub was taking up the class, actually last week, he talked about text blob, which is another way of going through an NLP problem. So and he talked about, we have three ways. We can use the packages actually. You can use the spaCy, you can use text blob, or you can use NLTK. And we were told to do more research about it. And of course, he gave some hints about the three. So in this case, we just decided to use spaCy, and then which we will use to model our different sentiments. So what will be different in what we are doing is we will use text as selected text for all the neutral tweets due to their high Jacquard similarity. So if you didn't attend the last class that we did for sentiment analysis, then it will be hard for you to understand why we are using Jacquard similarity. It's because we already defined it and we had a function and we calculated the Jacquard score. So we already know what decision we should make. So we decided to use selected text to use text as selected text because we found out that they're almost similar, hence leading to the high Jacquard similarity. Also, we decided to use text as selected text for all the tweets having number of words less than 3 in text. As explained before, we will train 2 different models for positive and negative tweets because we are not very interested in the neutral tweets. We'll just train for the positive and negative. Also, remember that the number of words, we found out that the lesser the number of words in the text, the higher the probability of that text being used as the selected text to determine the sentiment. So we will not pre-process the data because the selected text contains raw text. And also remember, we do not have labels in our data. So I hope you can all see. I see the font is really small, but I hope you can see.
I can maximize it.
Enlarge. Okay, please do.
That, how about that?
Yeah, that's okay.
Yeah, I mean, people. Hold on. Let me watch on the chat part of the book. People are suffering. Let me call names. Henry, were you able to see? Ama ulikuwa unavumilia kimwanaume. Josephat.
Ayub.
Yes?
Mimi niko sawa, nakula carrot sana.
Sawa. So unajua ingine yetu kama I have spectacles, so I'm assuming when someone complains font, maybe kuna watu wengi wanaumia. But come on,
Sure.
Omia, if you cannot hear, if you cannot see, please don't keep quiet. Let's follow through together. Back to you, Eunice.
Okay, thank you. So what we start with is we want to create a column with the number of text, the number of words in the text column. So we create a new column that is called num words underscore text in the trained data set. So that is how we do it. And then let me minimize this.
Which one do you want me to minimize?
Oh no, it's okay. It's okay. I can just see. It's fine. So just go back,
Okay.
kindly.
There.
Yeah, there. So this is where we're creating the new column, and then we want to drop the NAs. In our previous video, I will keep on referencing to that previous video so that anybody who has not watched goes back to watch it. So in our previous video, we realized that we have NAs. We have NAs in our data set. So we're dropping them here. And then we're saying drop NA in places equals to true. I know most of you know what this does. It ensures that the data that will be used through the notebook has no NAs, like it retains what you have done here. So just go down kidogo, we can see, okay, based on our JCAD score, we only want to deal with mostly with positive and negative tweets, as I explained earlier. So here, we know that if the number of words in the text and the number of words in the selected text are less or equal to 2, then we found out that those were mostly the neutral tweets. So we want to subset our data to only contain the number of words in the text that are greater or equal to 3. So this is what we are doing here. And then just down below, we can see, I have an explanation of why we decided to use spaCy. I decided to write all my comments here so that I don't forget to mention them. So we ended up using spaCy's already trained models for sentiment analysis, since we do not have labels in our data. So remember, when you're modeling when you're doing modeling, so that you predict, you can either create your own model from scratch, or you can use the documented trained models for the specific package that you're using. So for us, spaCy has already trained models that are documented and they are approved. So we decided to use them, and they were also provided in the competition. So we just decided to use them. And then because we do not have labels in our data, so it will be difficult for us to use our data to train the model. So we said we're using spaCy's models because these models are statistical in every decision they make. For example, which part of speech tag to assign, or whether a word is a named entity is a prediction. So you remember when Ayub took us through the text block, he talked about parts of speech, and I hope that everybody went through that video. So yeah, so in our models, when we are using these trained models, they are already manufactured to do this. They will do tokenization, and they will check the parts of speech, yeah, and all that. So down here we have a function that saves the model. So you can see this function saves the model to the given output directory. So it takes those 3 parameters. So we have our output directory that we have given, and then we are saying if the output directory is not there, then you make directory, make deals, this one, os.makedeals. For it will make that output directory if it does not exist. And then we can see we're saying save model to output directory. So that function, we're going to use it. And then down here, we can see we are passing the model. We want to pass the model to NLP if we want to train on top of the existing model. For our case, we already have an existing model, a trained model. So we have this function, the train, that we will use to train. We will use to now train down there. So you see it takes these 4 parameters. Okay, it takes even more than these. It's for you to decide which ones you want. So we have the train data that we will specify. and then we have the output directory that we have just talked about before, and then we have the iterations that we want. We are setting them to 20, and then model is equals to none. So we want to load the model, set up the pipeline, and train the entity recognizer. So if the model is not none, we are saying NLP is equals to spaCy.load output directory. So spaCy.load, if you had downloaded and installed a model, then this is how you load it. So this is how we are loading it. We are loading the existing spaCy model from the drive. And then if it's not there, if it's none, if it's none, this else is if it's none, then they say NLP is equals to spaCy.blank. So this will create a blank language class. And then the language classes that are in NLP, one is the EN, which is the English language. And then we have another one that is called EN_core_web_SM. So we preferred to go with the EN. And then we can see we are creating the built-in pipeline components and adding them to the pipeline. And then NLP create pipe works for built-ins that are registered with spaCy. So this is what we are doing down here. We are adding them to the pipelines, the components. And then we can see down there, we are adding the labels. This is a really long code, but you will understand maybe with further practice. And then we can see we are getting other names of other pipes to disable them during training, apart from the NER pipe. So what we are doing here in this section where Ayub is pointing, is it Ayub or me? Okay, yeah, there, we want to load all the pipes that are in our trained model, apart from the NER. We want to get rid of all the other pipes. We are disabling them and then remain with the NER. You can see if pipe not equal to NER, then it will disable all the other pipes because we only want to train the NER. So we can see then if model is none, then it will begin training. Else, if model is not none, it will resume training. So down there, you can see we are talking about the loss function. So I read about the loss function, and this is what I got from it. So the loss function calculates the difference between the training example and the expected output, gradient, and the updates we need to do to our model. So as much as possible, we need to reduce the loss function so that we can have the model that has the least error. So that is what we are doing here. And then we are using TQDM, which instantly makes our loops show a smart progress meter. So it enables our loops to progress. So you can see we are random shuffling them. We randomize the data to prevent the data from the model from memorizing. You can see we are doing the batches, and then we are going batch by batch so that to reduce, as we look for the model that will have the least error or loss function. So you can see, okay, you're also drop is equal to 0.5, where we're saying this will make it harder for the model to memorize data. Okay, so here we will be able to see the losses. Okay, we can just go to the next function. Okay, so here we just have functions. The next function is get model out path. So this is where you'll be able to get the path where the model has been stored. So we can see it returns model output path per given sentiment. So you'll have it only has one parameter, which is the sentiment. So when you're calling this function, you'll either specify whether you want the positive sentiment, model for the positive sentiment, model for the negative, yeah, or any model, or model for the neutral. So then we have the next function is get training data, and then it only has one parameter just as the other one. So this returns the training data in the format needed to train spaCy NER. So we can see here, train data, we're giving it an empty set. And then we're saying for index row in df train iterate, so it will iterate per the rows, and then it will take the row sentiment and give it to the sentiment, and then pick the selected text is equals to row dot selected text. Okay, yeah, and all that, and then it will return the train data. Then now we get into the two training models for negative and positive tweets. As we said, we're only training for these two. We don't need to train for the neutral because we already know that the selected text is the text. Here we are training so that we can be able to we're training the model so that we can be able to predict the selected text that has been used to provide the sentiment. So our sentiment is positive. Then remember, for train data, for get training data and get model output, we only had one parameter, which is the sentiment. So it will pick the sentiment that you have just assigned sentiment to. So, and then we are going to call the function train, which will train the data. You can see the iterations. We have given 3 iterations just to see how it goes. So you can see it will run the first one, that is 0%, which is a blank model, and then go to the first iteration, the second, and the third. And as you can see at the end here, we can see losses, NER 33, in the first one is 33, 180 point, that. So you can see as the iteration goes, the loss function reduces. You can see 330, started from 33,000, 30,000, now it's at 29. So what we can say from this model is this training, we can say that our model is good because as the iterations move, then the loss function is decreasing. It's supposed to decrease, but it's not supposed to get to 0. So if you train your model and then you get that the loss function is increasing, then you know your model is not right. Okay, then we say our model is good because the error is reducing. Then we go to sentiment is equals to negative. So this is where we are training now the negative sentiment. So we do the same thing, and as we can see at the end of our the loss function per iteration, it reduces. It was 31,000, goes to 28,000. Now it's at 26,000. So we can say as the iterations go by, then the loss function is reducing, meaning our model is good because the loss function is reducing, even though it's not tending to 0. Okay, then down there, now that we have trained our models, we can be able to use them now to predict with this trained model. Okay, now using this model, let's predict the selected text of the test data using the sentiment provided. Remember, as I said, the test data contains the text ID, the text ID, the text, and the sentiment. It does not have the selected text. So what they need you to do is to find out which text was picked to get the sentiment. So that is what we are going to predict here. So we come here, this is a function, predict entities. It contains two parameters, requires 2 parameters. So we can see doc is equals to model.text. So this doc is used especially when you want to call the NLP object. So we can see where we are starting and up to the length of the text, and then okay. So here we are returning the selected text. That is a function to predict our entities. And then down below we can see where we are assigning our selected text just below the next code, the next chunk. Okay, selected text, we are saying we are giving it to an empty bar, and then we're saying our model base path. This is where now our models have been stored. So it's there. So we have to specify the path, and then if model's path is not none, then it will print loading models from that path. So we have the positive model and we have the negative one. As you can see, we are spaCy.loading them, meaning they exist and we are spaCy loading them. Then you can see for index row in df test iterate. So this will iterate every row. And then if row.sentiment is equals to neutral, because we already have this column in our data set that contains the sentiment. We can see if it's neutral or the length of text.split. Text.split is where it split the words. So if we have I will come, it will be splitted to 1, 2, 3. So if the length of the splitted text is less or equal to 2, meaning the selected text and the text are equal, then the selected text will just append the text. Whatever is in the selected text will be picked by text. So that is for the neutral. And then for the positive, you can see we are saying predict entities, the predict entities function that we just defined up there. Then we are picking the positive model, and then we are using the text to predict. Also for the negative, we are using the text and the model negative to predict. Then we say here, df test, because we do not have this column that is called selected text in our test data, we create this column, selected text is equals to selected text, this the one that we have just predicted. So there's a comment here, a new column called selected text takes the selected text that have been predicted. And then just down, we can see the submission data now has the selected text column that was predicted in the test data. So we pick our submission data. We create a new column called selected text. Oh, sorry, there. We pick the submission data. Remember, I told you that the submission data only has the text ID. It does not have anything else. So we want to create a new column called selected text that will take the selected text that has been predicted in the test data. And then we are saving it to a CSV. And then we want to display the first 10 to see how it looks. So we see we only had the text ID, but now we can be able to predict. We already predicted that the selected text for this ID is this, and then for the other one is this. And then down there, we also assigned the, just scroll down a bit. Down there, we also created the sentiment column also that takes the sentiment column in the DF test. So you can see now we have the selected text and we have the sentiment. Yeah, so that is all. That is all. I know.
Zoom should have a place where people clap and shout.
Yeah, sure. Yeah, so that's it. And if there are any questions, you can let me know. We will be here to answer them.
Yeah, I need to join that person who was clapping. How do I clap?
Yeah, man.
Thank you.
Maswali,
okay, so if you have any questions.
Okay, Eunice, I think this has been really, really good.
Yeah.
There are guys who joined a bit late and maybe they might have missed you. I had guys who are, some guys inboxed me that you were breaking. So I would like to, given the chance, I would like to just put it into context. Immediately after we get questions. I know people have questions, but in case we don't get questions, I would want to put what you've just done, you and Brian, I would want to put it into context and provide even a hint on the projects, the kind of projects that we will be doing moving forward. This is really good work. So let's open the floor for the questions.
Okay. Lillian was talking, I think.
Yes, Lillian, please go ahead.
Sorry, hi, yes,
Hi.
Hi, Lillian.
Yeah, like I think like I was saying, yeah, good job on this. Yeah, so maybe my question is, you have this on GitHub already? Because I'd like to like go through it and maybe Yeah, because I think there are, other than spaCy, I'm sure there are other ways of using the same data, but using different models. Yeah.
Yeah.
Okay.
Okay, sure. Yeah, so we only have the first session that we did, which was 2 weeks ago, was whatever we did is on GitHub, but this one, because we were preparing it for the presentation, then when we are done with the presentation, that's when we take it to GitHub. So maybe once we have that, we can share the link.
Okay, so that will be good.
Thank you.
Yeah, all right. Yeah, but like, yeah, good job.
Thank you. Ayub?
Yes.
Lillian has talked about the other ways the other models that you can use. So remember you taking us through the text blob, and then we talked about NLTK, and then we talked about this spaCy. So I think there are differences that you mentioned which could be very useful right now.
Yeah.
Okay.
Yeah,
so kindly.
All right. Sure. spaCy is for start. spaCy is lighter and faster as compared to text blob and NLTK. And then when you're working with NLTK, the steps that you choose are quite a number. You have to do one and then do another. spaCy puts all that in a pipeline. I'll just review that in when I'm putting all this stuff into context. So speed for start, and then ease of use and simplicity of spaCy makes spaCy really preferred in doing some of these, most of these NLP tasks. But there are people who normally, people can choose to use NLTK for one reason or another, but spaCy, when it comes to named entity recognitions, it is above all of them, extracting entities from sentences. So some people would separate the two, like now, let me build my models using NLTK purely. So when it comes to tokenization, lemmatization, all those things that we were talking about previously, let me use NLTK, and then bundled up, when the time comes when I want now to extract entities from my text, let me bring on board spaCy. So it depends on the design of the ML engineer, like now what the ML engineer wants to do. I think that's sort of like put it together. I'm not so sure. Eunice?
Yeah, it does. It actually does. I think we will see more of that in context.
All right.
Yeah.
Maswali ingine? Timo?
I had a question, but you've just explained it.
Okay.
Yes.
Unajua, me I like calling names, so especially Dennis, they know I can see you logged in today on time. Uko na swali?
Hapana, sina swali.
Uko poa? All right. Who else? Why not? Who else? Devi Mombali. I know you've been really keen on NLP from the beginning. Do you have any question?
Yeah. So thank you for giving me the floor. So I had one, like, I have many questions actually. The first one, I want to ask Eunice, why does she have two models for positive and negative? Why can't you just use one for the positive sentiment and negative sentiment?
Eunice, did you hear that?
Yeah, I heard that. Oh, I thought he was proceeding with other questions.
Maybe after answering that question.
Okay, so okay, we have three sentiments. Remember, we have the positive, negative, and the neutral one. So we decided to model the positive and the negative sentiment because separately, because the different text, selected text that has been used to determine the sentiment. Okay, the text that has been used to determine the positive sentiment and the one used to determine the negative sentiment, is different. So we decided to, okay, is there a way I could really model both sentiments with one model really? I think the model will be confused.
Oh, okay. Because the way I'm looking at it is, it's like you are trying to predict either it's 0 or 1, maybe 0, 1 or 2, and you can use simple, maybe logistic regression to solve the problem. So I was wondering, what did you want to use two models, like one for positive and the other one for negative? Maybe you can
Okay.
answer that question.
Oh, okay. I get your question, and Eunice, you're absolutely right. Let me put it this way. So you see, we have several statements. Some are positive, some are negative. And then within those statements, there are specific texts. Like, let me say, a statement like, the fisherman went to the bank. Yeah. And after going to the bank, he went to the supermarket called Nakumat to do shopping for their kids. So you might want to do some stuff like now finding out what exactly did the fisherman do from that statement. So using spaCy, you're able to extract the fact that there is shopping. There is a way you can actually extract the roots of, the root is basically what exactly is behind the intent of that statement. So the root of that statement I've just given is shopping. But now you've picked the root as shopping. But now, what if you wanted to ask yourself, where did the shopping occur? You need to extract the name of Nakumat, for instance. Now that is now the name entity recognition. So using spaCy, you can actually train the model to extract any a supermarket, for instance. And in this event, it will go and extract Nakumat as the entity. So if you are to pass this knowledge to, say, a chatbot logic, the root would be shopping, and the root and the shopping was done from Nakumat. Now, if we come back to sentiment, it's the same thing. You look at a complete statement, and you want to now pick which are these words that actually were used to these words that were used for predicting whether, or rather, a positive sentiment or a negative sentiment. Okay, so if you pass documents if you pass strings of text to your spaCy model, to create your document, and your intent, like I believe that was the intent of Eunice and Brian, your intent was to extract the words used from the words that were used in that prediction for positive sentiments, and also see the words that were used to determine the negative sentiments. So I believe that is why it was separated. But if it was for a general a prediction, like now you just want to extract general entities from text, like I gave an example of getting the name of the supermarket, then there is no need of splitting it the way it has been done. And I also think, just to add on to what Eunice said, I also think, David, you're right when you say you could actually just go and extract those names regardless of what it was predicted. But what you will train the model, you'll need to train the model now with a more generalized, what is it called? With a more generalized corpus. You see, Eunice and Brian opted to separate the corpus into positive, neutral, and negative, and then from within which the words are extracted, or the specific text are predicted. So I think it's also a preference. There's no harm. I find it easier if you split it, because the words are normally different. Does it make sense, David?
Yeah, it makes sense. Thank you. I think I'll go through the notebook and try to understand. If I have any question, I can ask her.
Sure.
Yeah, but I want to ask, the previous notebook, has it been shared already?
Yeah, we shared the GitHub link. You don't read messages on the WhatsApp
The
group.
WhatsApp, I know the
I
WhatsApp.
do, I
Normally, at
do.
times we swarm it with a lot of messages.
Oh, yeah.
Yeah.
Yeah, it was shared. I remember it was shared. I think at the same day we just finished. The day, was it the same day or 2 days later?
It was like 2 days later by Brian.
Okay.
Yeah.
Okay, thank you.
Have you any other question?
No,
You're
I'm
good.
okay.
All right, Henry. Henry, fungua roho, kuna swali yote?
Hi guys, I don't think I have a question, but maybe a comment or an
Did we lose Henry? Henry, I think
actually based on what maybe Ayub had mentioned previously, where we bring in maybe text blobs.
yes, go ahead. I can hear you, Henry.
Ayub. Oh, sorry for that internet disconnection. I'm saying not really a question, but something I would want to mention on when you're talking about maybe when or why we would use text blob or maybe spaCy or maybe NLTK. I'm actually trying to marry them all based on what we've been doing. Because I remember when uni started, I asked a question on the initial data set, which had been classified as at the beginning, such that we had a data set that had positive, negative, and neutral sentiments. So I'm like, can we really classify our raw texts using spaCy? Because yes, we did with text blob and we saw how it does it. So maybe I was thinking we when we are working with raw data, or maybe we are starting a project from the scratch, at the beginning we'll maybe employ the use of text blob to first classify the text, then maybe
Oops, we lost you again, Henry.
doing modeling is when now we can bring in spaCy or an NLTK. I don't know. I was just trying to think all around on what we've been doing. You can clarify or maybe chip in.
Yes, I agree with you, Henry. I think that would be the best approach, because you see, for instance, when we pick a project and the project is going to scrap data from Twitter, for instance, those texts will not have labels. So we can start from your points, just the way you said it, from text blob and then advance to spaCy, and we'll see all these things that we've been learning pan out, and we'll get more and more comfortable and internalize some of these concepts. So I completely agree with your approach.
Just to add a few to what you just said, Robert. Can you hear me, Ayub?
Yes. Go ahead, Eunice.
Oh, okay. To add on what you said, as we plan to have a project like from scratch, like from the way we want to scrap out data from Twitter, classify, do the modeling and whatnot, maybe have hypotheses and stuff later on. So I think that will be a step-by-step procedure that will open our eyes, and I think everybody should look forward to that. And also, as they wait for that, they should go through what we have already done so that they have basic ideas of what our aim is.
Absolutely.
Yeah.
Nani sijamulika hapa? Josephat, you won't hide. Ama umeongea? Jose.
Yes, sir. Niaje Ayub.
Poa sana. Fungua roho, uko na swali?
Manze, it's been time manze, sija nini manze, nilikuwa na focus sana na mambo ya web development, but na catch up.
Karibu sana. Karibu sana. So with your skills that you may acquire for web development, at the right time you will actually help the team on how to deploy it, the model, and expose it to a web. So have that in mind. So you will play a key role in helping the team understand some basic aspects of web.
Okay.
Hiyo si ni sawa? Ama nimekuseti?
Yeah, iko sawa.
Sawa. Aya, nani hajaongea hapa? Brayo, hebu ongea.
Hello. Hope you guys can hear me, right?
Yes.
Yeah.
First, I wish to apologize for my delay. I think I came when Eunice had just already finished. Some things came up just when you think you're done. Yeah. But I think the journey is fine. We are all learning and it's getting better. That's just what I can encourage guys here. Like, we are all learning, and each day we are taking pieces and putting them together. Soon we will have everything together, and that's what we are looking forward to.
Awesome.
Sure.
Okay, so I think there is one more guy who just came when you were wrapping up. But before ni mulike, anaitwa I am Goni.
I have a question.
Yes. Yes, ask. That was Henry.
Hear me?
Yes, now
Yes,
I can hear you. Okay, I lost you again.
Maybe you can elaborate where are we? Model imeisha, are we, what is remaining? And maybe if you can run the cells to see.
Oh, okay.
Can you hear me?
Yes. I've gotten the question. Actually, I wanted to put everything into context in terms of where we are, and then give some direction. Ngoja ni mute huyo. Haitoki kwangu. Nilikuwa natoka kwa Eunice. Okay, Eunice. Sawa. Don't unmute. So I was saying, I was just about to put everything into context, what we've covered so far, and how this plugs into the whole learning path, and give some hints on where we are going and where we hope to be. But before I do that, I would want to allow I am going to say one or two things. We are finishing, but I'm hoping that I will be able to do justice to what Eunice has taught us today in like 5 minutes for the sake of the guy who just joined us a bit late. So before I continue, I am Goni. Hiyo ni jina yako ama hiyo ni brand name? Hebu tuambie. Over to you.
Thank you, but I don't have anything to say. I'm just watching for today.
All right, karibu sana. So I noticed you came a bit late. What's your real name?
Ngoni Zashe.
Sorry?
Ngoni.
Okay. Karibu sana Ngoni. You're most welcome.
Okay, thank you.
All right. So for the sake of everyone, we started with the foundations to machine learning. And then from foundations to machine learning, it branches. One of the branches is NLP. NLP, we've had a couple of videos, I think 3 or 4. This is the fifth video. And each video touches on a few concepts. And the concepts that we've touched so far, we've touched on a sentiment analysis from scratch to end, where you can predict the sentiments. We've touched on some NLP pre-processing tasks like tokenization, limmatization, what they mean, when we were using NLTK. And then the last video, we also spoke about text blob and how it can come in handy, especially when you don't have labeled data and tagged data. Just for a start, very, very basic, and it's normally a very good intro to NLP tasks. Today we've covered spaCy, right? So anyone who wants to really benefit out of all these sessions to the end and be a very good, like comfortable in NLP tasks, comfortable to the level where you can actually attend interviews and answer questions like a pro, and also either deliver solutions and problems along NLP, then I propose that you create time, go through the audio, the videos. Not only do you go through the videos, ask questions and get answers to your questions satisfactorily. If you don't get satisfactory answers, go get answers from the net and come and challenge a line of thought, because here we are all learning. So you might have a perception that is different from another person. That is allowed. So feel free and let's engage. That is one recommendation. Another recommendation is besides going through past videos, purpose to attend future videos, future classes, not only videos, but the classes you shouldn't miss, because a lot goes on in during classes. And then take it upon yourself to do more research by yourself and come and contribute in class, and feel free to ask questions and we will answer, right? So that is about recommendation. Now, a quick 5-minute summary for the sake of Goni of about what we were doing today. We looked at sentiment analysis, a continuation of the previous class, and we wanted to introduce a library called spaCy, and introducing it specifically to learn how to extract specific entities from text. So, for instance, if you're building a chatbot using a basic classification, a classifier, or basically a retrieval-based chatbot, you'd want to know how to extract specific words from a sentence. If it's an IT support chatbot that is supposed to automatically reset passwords, for instance, or automatically create certain tickets. So you'd want to know the department of this individual, or if it is mentioned, or you'd want to know the machine name. So someone sends you a text like, I'm using Windows 10 and I'm getting this error. So from that text, are you able to automatically pick the operating system mentioned by the staff? So these are some of the scenarios within which you can apply named entity recognition, and the best library to use is spaCy. Yeah, if you're working on stock, you guys just think through instances where someone gives you verbatim in terms of text, and how do you go ahead and extract certain important words. For instance, if you a basic sentence like, my name is Ayub and I'd like to talk to the manager of IT division. I'm here on an appointment and he or she is aware of my visit. So if it is on a book, an appointment booking chatbot, you'd want to get the name of this person. You want to get the person who needs to be seen. You want to know the department where this person who needs to be seen is, and then go and check their calendar if they're available. If they're available and actually wanted to meet Ayub, then you immediately respond to Ayub. He's waiting for you in 3rd floor. Walk this, like this, automated, nothing. Yeah, so those are some of the basic scenarios that can come through your mind, and that was today's class. So that is how important today's class was. It has introduced us to how to extract entities from text. Now, within the context of sentiment analysis. So Eunice took us through looking at positive sentences, looking at negative sentences, and she mentioned about pipes. She mentioned about quite a number of things. A pipe was basically components. So in a pipeline, there are several components. For instance, when you're using an LTK, we have tokenized, you have to tokenize, you have to lematize, you have to step by step. So spaCy puts all this together in a pipeline, and in the code there was somewhere where she was removing those other ones and remaining with named entity recognition. So she removed tokenizers, she removed all the parsers, she was left with named entity recognition because that was the context within which we were learning today. So that is what we have learned today, and that is what, in summary, that's what we've learned in the past. Moving forward, we are going to pick a project, and it's going to be an NLP project. We've not yet settled on one. We're going to pick a project. If you have project ideas, feel free to push it on the wall. We will consider it depending on the amount of workload it requires, but we are looking at completing an NLP project end-to-end, a solution that can be accessed by the public in a not more than 3 months. Not more than 3 months. So since we are not working on a daily basis, like we are not having classes on a daily basis, it's only 1 day per week. You might think that 3 months is long, but in actual sense, it's very short. So propose to attend the classes. So we will, moving forward, we'll pick a project and we will start from scratch, and we are going to scrap data from either Twitter or any website, depending on the project that we are going to do. And you will walk this journey one more time, coding, and we will expect much more engagement moving forward. So if you're lost, don't feel lost. We are still together, and there is no timeline apart from the timeline within which we can complete our project. I think that is it from me, unless iko swali. Someone asked if we are going to get code from GitHub. They're going to share the code from the collab notebook. They will share, and this class session was recorded. You guys will also have the audio recording for this class session. So everything will be accessed. And Eunice has responded, yes, she will share the link.
I have a final question.
Yes, Timo.
I heard you saying that you had started also from foundations up to NLP. So the one for Saturday where we do foundations to AI, will it still be there?
Yeah, foundations will still be there, especially for those guys who are yet to grasp the foundations. But if you grasp the foundation, I immediately recommend you jump into a project, because some concepts in foundations will be repeated in projects. So you see, the first time you hear about something, you won't quite get it much, but the second time, it will give you more sense. So let the first class be foundations, where more or less you're listening to things the very first time. But now, once we walk through the foundation, that is the purpose of the foundation, for you just to, ni kama unapewa ball, unaenda kiwanjani kabla mwanze kucheza, unapewa ball hapo, unapiga, unaona, it doesn't mean utakuwa kwa playlist, but at least umepiga hiyo ball na umeishika, kama ni goalkeeper umeishika. Yeah. So the foundation class will still be there. It will be on and off, but the target will be new guys. So, but if you walk through the foundation class, I strongly believe you guys are ready to pick a project and continue running. You don't want to end up in something I call analysis paralysis. You get stuck in one place forever. Timo, does that answer your question?
Yeah, that's good. That's fine.
Okay. Kuna swali lingine? Eunice and Brian, thank you very much for this class. It's been real. spaCy is really awesome, and we are going to use spaCy very a lot, very much. Gosh, I think the meeting needs to come to an end. Very a lot. And with that, I thank you guys for attending. Remember, your learning is in your hands. With groups like this, don't miss. You miss, you will only see people move and you're left behind. Thank you guys, and have a lovely evening. We meet again next week, Wednesday. Cheers, guys.
Yes,
Thanks,
bye.
Bye.
Thank you.
Bye-bye.
Thanks, Ines. Bye, guys.
Thank you.
Bye.